All right, so now let's see if we recall this. So it says your directions, given the graph of the parent function, so this is the function that we're basing everything off of again, and that's what you're given to look at. And a list of transformation, graph the new parabola and write its function in vertex form here. So try that real quick. Try number one without me doing one yet. We spent 3 days on this last week, Wednesday through Friday. You did homework on it, even more. So let's see if we retain any of that through the weekend. Mr. Kubwitz, don't mark Megan absent. We're messaging. She's not able to get on. So
okay, thank you for letting me know.
Yeah,
I had her marked absent.
Okay, thank you. All right, Cam, what are you going to give me? The equation?
I think the vertex form is -2, -5.
Okay, so let's talk about this first. Let's write. So here is here's our parent function. So the way we're going to now write this, if I can erase it, is what goes in right here is that left or right shift. So what did you think it was now? If we went left 2, what would this equation look like?
Wouldn't that be -2 right there?
Here? Okay, we'll talk about that in a minute. We'll see if everybody agrees. And then what would we have back here if we're going down 5?
-5.
And then Cam says a -5 there. There was a 1 in front of this here. We didn't talk about making that narrower or wider, so that's going to remain a 1. So that's definitely good. What do we think about the x minus 2 and then the -5? Do we all agree with that? Nora?
For the x minus 2, it's supposed to be x plus 2.
All right, Nora thinks it's supposed to be x plus a 2. And I'm going to go Vicky. Break the tie, Vicky. Is it an x minus 2 or an x plus 2? Yeah, should be a plus 2, okay, Cam? So here's how, honestly, I still kind of remember it this way. In the parentheses, it's kind of the opposite of what you would think is happening. So since I have a plus 2, think kind of the opposite. Inside the parentheses, if it's a plus 2, I'm actually going to go left 2. And then on the outside, it is what you would intuitively think. If I have a -5, that's going to take me down 5. All right, Cam? Okay, then we wanted to graph that. So all that means, take your vertex here. We're going to go left 2, so 1, 2, and then take it down 5. 1, 2, 3, 4, 5. I'm going to ask you to do 2 more nice points. So 2 more actual points and not sketch it too much. Notice how it goes through 1, 1. That point would also go left 2, down 5. So 1, 2, and then 1, 2, 3, 4, 5. And then this point would also go left 2, 1, 2, and then 1, 2, 3, 4, 5. Notice how there's a 1 in front of this. This is something we're going to talk about in due time, so we'll do a little teaser right now. So notice how there is a 1 in front of this here. And then notice how in order to get from the vertex right here, this big fat one is the vertex, to this next point, notice how I would go up 1, right 1. That's not a coincidence. I can go to this point over here by going up 1, left 1. That corresponds to this number in front. And we're going to show one here in a second how it's going to correspond also when it's not just a 1. All right, so that's important. Kind of make a mental note of that. All right, number 2, do that one real quick. Let's see what we think. All right, Cam, you got your equation?
Yep.
Okay, I just want to see if you now understood kind of what happened in the last one and see if we get it corrected this time. All right, so what do you think for the equation?
Y equals 1, and then in parentheses, x minus 3, and then plus 1.
All right, what do we think this time for Cam? All right, you're getting a lot of good head nods this time, Cam. Good. So if we're going to go right 3, again, it's kind of the opposite of what you would think. We actually want to do a minus of 3 in here, and then the one on the outside would keep the sign that you would think it would have. It stayed a 1 because that's what this one was, and you weren't told to do any shifts with that. So take your vertex now, move it right 3 up 1. So 1, 2, 3, up 1. And then again, notice how there is a 1 right here. That's important. It's going to become more important. All that means we could do for this next point, from this vertex, just go up 1, right 1. That'll take us to a point. And from this point, go up 1, left 1. That's going to take us to another point, and then we can start to sketch that thing in. I guess I never did sketch this one in over here, but then we can sketch that in. If we would have done the same thing with our point, so let's say I would have taken this point right here, that's on the parabola, and again, do right 3 up 1. I would go 1, 2, 3. Notice how it takes me right to that point. All right. All right, so now the last one. See what you think about this one. All right, I am going to pick, let's see here, Jennifer. You looked up right when I said that, Jennifer. Whether you know it or not, you made eye contact with me, so you're the winner.
I put y equals 1 parentheses x plus 4 squared plus 2.
All right, do we agree with Jennifer? You had a mixed response there, Jennifer. I don't know if you can see everybody. Some said yes, some said no. All right, anybody who said no, want to say why? All right, Nora, what do you think?
Wouldn't it be like the 1 would be negative since it's being reflected over the x-axis?
All right, good. So remember some old constructions last year with your Math 1 teacher, and you would do a reflection around the x-axis. So if I reflected this one around the x-axis, remember how that would create kind of a mirror image? So if I reflect this vertical parabola, wouldn't the reflection then create a parabola that opens downwards? All right, so for the first one here, seeing this word reflect, you had to kind of remember what that was. That's just telling us that we're going to flip our parabola upside down. So everything Jennifer has here is great, except we just want to reflect the idea that we're flipping our parabola upside down, so we are going to make our 1 a negative. All right, good with that, Jennifer? Okay. And then we can move that if you want, and actually draw this. So it's still 0, 0. We're going to go left 4, up 2. So 1, 2, 3, 4, but then go up 1, 2. Now that we know it's opening downward, see this negative 1? Now I'm going to go down 1, right 1, and then down 1, left 1, and then we can sketch in that rough draft of the parabola. All right? Okay, good. Okay, y'all got that? Move this. All right, here we go. Okay, it says 2.2 more transformations of parabolas. So just going to add some layers here. So when it says the y values or the output values are multiplied by some scale factor, we say that that function has been, you're going to put in the word dilated. You would have talked about this a little bit last. I don't know if we use the word dilated in Math 1, but it's when we basically make bigger or smaller. I think that is something we do specifically in Math 2. So when it says, when the graph has become narrower, so remember how we would make that narrower? Now, this is sort of counterintuitive. It's actually probably the opposite of what we would have talked about in the day when we talked about this. But when this gets narrower like this versus wider, so like this is it, let's say this is the narrow one, this is our wider one. What this is actually called has been stretched. It's been stretched vertically. We can do it stretching vertically or horizontally depending on if the parabola opens up or to the left or right. But we basically have, think of the original parabola as a rubber band. And if you could grab the rubber band here and here, and from here pull upwards, notice how that stretches this thing out vertically. All right. So we've stretched it. All right. When the function becomes wider, again, it's kind of the opposite of what you would think. We would actually call this compressed. All right. When it gets wider, we've compressed it, which is, again, kind of the opposite of what we talked about before. But those are the official math things. All right. So that's what we're talking about here. Stretched or compressed from the parent function. That's all you're going to tell me right now. So just get used to this vocabulary and write this down. So if we got, think narrower. So really what stretched means is our parabola got more narrow. And what compressed means, and to me this kind of is the opposite, is kind of counterintuitive a little bit. It gets wider. So instead of using words like narrow and wider, these are the official math words. And fill those in. See what you think. So if we have a 3, a 1/5, a 5/4, and a -2, did we stretch it or did we compress it? All right, so if we get narrower, you're going to say that it got stretched. If we got wider, then you got compressed. All right, so number 1, Michael, what do you got there? If we have this 3 in front, that's going to do what?
I put compressed.
So let me get this. If we put the 3 in front of it, what this should do is make our parabola wider. I'm sorry, narrower. And what narrower what's that?
Nothing.
And what we do, if we do narrower is called vertically stretching it. We're pulling that thing up and we're stretching it vertically. Okay, so it's, again, kind of the opposite of what we would think. Oops, wrong color. And it might even been opposite of what we wrote down the other day. All right, so we've stretched that thing up vertically. Yeah, Cam.
Didn't we say like last week that if the number's bigger than 1, something will happen, and if it's smaller than 1, something else will happen?
Correct.
So like whenever it's bigger than 1, it's going to be stretched, and then whenever it's smaller than 1, it's going to be compressed, right?
Correct.
Okay.
Yep. I mean, we could add that here as part of this little equation here. When it becomes narrower and we stretch it vertically, it's because our a is greater than 1. So we could add that to that line right here. And then here, if our a is less than 1 but still greater than 0, then that's going to make it wider, which we say is compressing it. Okay. Now, don't worry about the negative here. The negative just tells us that we're opening downwards. That's all that's referencing. What we're concerned about is this 1/5, and is it greater than 1, or is the 1/5 between a 0 and a 1? All right, and I think we all know 1/5 is between 0 and 1. So that should get compressed. All right. 5/4. If you have 5 quarters, like a quarter, anytime we divide by 4, it's a quarter. So 5 quarters is over $1. It's $1.25. So that would be this up here. Our A is greater than a 1. That's going to give us a narrower parabola. And narrower parabolas are what we say they get stretched. All right. The last one, the negative, is just telling us that we go downwards. The 2 is greater than a 1, so that one would also be getting stretched. All right. All right. So that's. See if we can get through one of these. We'll finish the day off with these, put one of these together. So it says, for each function below, determine the transformation, so reflection, dilation, translation, that must be performed on the parent function in order to graph the indicated function. And then basically just all the stuff that we were doing last week, the vertex, axis symmetry, and then the table and the graph. All right, so for this one, we should have 3 things going on here that we could write. Give me the vertex, axis of symmetry, and then see if we can set up that table. All right, so Nico, give me one of the transformations. What's one of those 3 bullets? What happened to our graph?
I said that it went down or up 7.
Okay, you agree with Nico? Why is it up 7, Nico? Why do you think it's up 7?
Because it's there's a -7 outside the.
Okay, so outside of the parentheses, just go what you would think that -7 means. It's exactly probably what we would normally think would happen. If I decrease by 7, that would cause me to drop 7. So that one is going to keep kind of what you think that sign would stand for. So we're going to go down 7. Come on. Where's my eraser? So we're going to go down 7. All right, so then on that point, then Nico, this is the one here. When we start talking left or right, a -5 might make us think we're going to go left 5. But that's the one you actually kind of think the opposite of what you would think would happen. So a -5 is actually going to move us to the right 5. Okay. All right, and then Rebecca, what's the third thing we should have down here that happened to this graph?
I put up. It's like going upwards.
Good. It's
Like
go.
opening upwards.
Okay, good. So we could actually put 4 things, I suppose. All right, and then somebody got the 4th thing. What's the? Yeah, Cam.
Oh, it's being stretched.
Good. It's going to be stretched, which in more normal words means it's going to be a narrower parabola because the 2 is greater than 1. All right. And then Nick, what do you think for the vertex, Nick? If I went right 5, down 7.
Would be comma, -5, -7, parentheses.
Okay, like that?
Yeah, like that.
Okay. All right, so this is good because this is probably now about the 4th time today. We're getting on people here, calling on people. It is the X that you need to be really, really careful of. All right, and we're noticing some people kind of getting that mixed up, and that's totally fine. All right, it's every single year, every time parabolas get covered, that's the one that causes the issue. If it's a -5 here, if we go right 5, which is correct, then what that actually means, Nick, is that we're actually going to have an X coordinate of a +5. So think about if I start at 0, 0, and I go right 5. So won't we be over here at a +5? Okay, and that's okay. Like that's the biggest thing to keep straight on this. All right, and then Vicky, what do you think for our axis of symmetry?
Is it x equals 5?
Good. And then it's got to go through this X coordinate of 5. So the X coordinate has, or the axis of symmetry has to be X equals 5. We go to our table then. I showed you now how to make this a little bit simpler. If you have your calculator, we know we're going to do 5, 7 is the vertex. And then we would just want 3, 4, 5, 6, and 7 to plug in. And then we're going to plug those in, at least to start with, knowing that whatever I get for 6, I would also get for 4. So let's do the 6 first. So let your X be a 6. If you have your calculator, you can put it into the calculator and look at the table. It'll do the table for you. 1 squared is 1 and then 2, and then minus a 7. And we should get -5. Hold on. Yeah. Hold on. This should be a -7. I'm confusing myself. So if this is a -5, this is a -7. Let's plot those points real quick. So let's plot those. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And then 4. 1, 2, 3, 4. Because what I want you to now see, and we'll do the last couple of points here in a second. Notice how this number in front was a 2 here. All right, see how that's a 2? When we look at this point, the vertex, notice how far up we had to go to get to those next 2 points. See how I had to go up 1, up 2, and then right 1, and then up 2, left 1? That's because of this guy right there. Which again, as we get to doing these a little bit later, that's going to become a little bit more important. All right, and then if we do the last one, gotta hurry now. Let's see here. Come on. Take our original equation, x minus 5 squared minus a 7. Plug in this 7 here. So we get 2, 7 minus 5 squared minus a 7. 7 minus 5 gives us a 2. Ooh, that's bad. 7 times 4 then, minus a 7. Wow, this doesn't seem right. Did I do that right? Oh, I can't read my own handwriting, sorry. These are 2s. 2. 2. 2. That's going to look better. And then we should get 8 minus 7, which should be a 1. So we would be here, here, and then we can draw our parabola. All right. All right, with that, no homework. We're gonna hit on some of these again tomorrow. Hopefully by the end of tomorrow, we'll be able to do that. Plan on a quiz Thursday or Friday. We don't have school Wednesday, so we're not meeting on Wednesday. So we'll try to finish this tomorrow. I'd like to do maybe a little review of it all on Thursday and then do a quiz on Friday. All right, so that's hopefully the rest of our week. So bring us tomorrow. We'll knock this out, and then that's it. All right. Get the third period. All right. Have a good day. We'll see you guys tomorrow.
Have a good day.